Hi everyone. Let's get started with Module 1. So as you looked over the student activity, you were able to see at least the first part talks a little bit about the background of what was going on in Flint, Michigan. Now the EPA has a rule, and Mark Edwards was going out to try to check the water after hearing some pretty scary results. So what's interesting about this first part, and perhaps the piece that a lot of students have trouble with, is the fact that when you measure lead in the water, we are measuring it in terms of parts per billion, which is a quantitative variable. So if it's numerical, they tend to want to think of it in a particular way. However, what we do when we're measuring that is we lump it into two categories, and we use a cutoff of 15 parts per billion. So you have two categories here, and we're checking to see what percentage of the data has this 15 parts per billion or above. So that's the piece I think that if you were looking at it, students are probably going to struggle with a little bit at this. So it's good to take the time for that first one that says write down the information. And what does it say about the data? So the data we're considering is really, at the end of the day, it's going to be categorical data. So we'll be looking for proportions. Now, as you moved on down to numbers 2 and 3, the goal here is to try to understand what was really happening in Flint. And so Mark Edwards did send out 300 water sample kits. He sent them out fairly randomly, received back 252, which is an amazing amount. It just shows how much people in that city really wanted to know what was going on with their water. And out of the 252, 42 of those showed lead levels over 15 parts per billion. We will simulate getting back 252 samples, just like he did, assuming though that the city has exactly 10% of homes that are exceeding that limit. So we're going to start with that assumption, and the information that I have here shows you how to use the Art of Stat web app. Put a little note to yourself, and again, you will get both the Word file and the PDF file if you need to make changes to this based on the technology that you use in your class. That's perfectly fine. At the end of this, we ask students to record their actual result. What was the outcome? And so the outcome that you could get is, remember there are two pieces, it's either 15 parts per billion or above, or it's not, it's less than that. And then, to kind of get them into the idea that we are dealing with categorical variables, we have them go through, fill out this table, putting in their sample size, what fraction meets each of the two options, and what percent that is. And again, the claim was it's supposed to be 10% for the city. And if you pull values from a population that has that 10%, does it match? And this is a great opportunity for a discussion about what does it mean to have 10% for the city, as well as bringing back up the idea of variability. Now, a teaching tip here at this point, once you've got a whole bunch of students with their individual one simulation results, if you're trying to have more feedback between everyone, it's a great opportunity to either bring them to the whiteboard or in front of the class. You could hang some post-it notes, large post-it note ones, and they can put down their information on there just to kind of show what does the distribution look like when we start bringing in a number of samples. If you're doing this online, you can also, if you're using Zoom, you could do Zoom Annotate and have people you share your screen and they can actually draw where their sample would be located on the grid. That's a pretty nice way to get everybody actively engaged. Be careful, of course, as you know with Zoom annotation, it may not work well for Chromebooks and other tablets. If that happens, just have the students send you a chat message with their results and you can add the little dot for them. So we're going to go through this process to kind of illustrate what happens with the technology. And just so you're aware, you can always use the technology shown by your textbook, your school, or your department. That's perfectly fine. We're going to show something that is completely free using the Art of Stat web apps. Again, free for anyone. We found they're extremely intuitive for students to use, and it links up with the ideas that we're teaching which is the computation isn't the critical component. All right, let's take a look now at those web apps. So to get to the Art of Stat web apps, you can just type it in, Art of Stat web apps. You can Google it. Once you go there the first time, you'll get to web apps for Art of Stat. Should be the first thing that comes up, and here's the entire collection of the web apps. You'll also notice that there is a section here for mobile apps, so they have been developing some mobile apps as well. For what we're doing, we're going to stick to the web apps because your phone browser can use these, and it actually does a really good job. Okay, so we're going to go ahead and scroll down. You'll notice it has categories, exploratory data analysis, typically the way you might start a course, association, correlation, and regression. For some, it might be near the beginning. For others, it might be near the end. There's a piece on distributions, and then sampling distributions. And so we're going to go to the sampling distribution for the sample proportion because we have categorical data. And if you click on that link, it does bring you into a place where you can simulate. Okay, so I'm going to go ahead and click on Enter Numerical Values. We know it's 10%, and we know our sample size was 252. When I click Provide Labels, so now 10%, which is the success, the 10% would actually represent the bad. So this would be high lead levels, 15 ppb plus. And the other one, a lot of times, just use what students do. Just say, not that high. I mean, it's really up to them. They could choose other language, but as long as it communicates the idea, I don't tend to get hung up on the wording too much. What I'm going to do now is when you're ready, you come down here and click Draw a Sample. And when you're ready, that is my sample. What I got a chance to see here is my sample proportion was 0.0992. There were 25 successes and 227 failures. So as we can see, there were not very many that were in the high lead levels, and there were quite a few more frequency-wise that were in the not that high. Now you'll notice my sample proportion, my p-hat, is a little bit under 10%, but it marks it there with a little blue line. And this is where you could have students choosing to kind of say, okay, let me put mine on the board with everybody else's, kind of see where did mine turn up. You could do that either with numeric values or with the sample proportion values, more as a percentage. Now for the second part, after you've finished that and you move on down, I did ask you to go ahead and make 1,501 samples, and it's additive, so I didn't want to have to reset. So if you go to 100 and click Draw Samples, I now have 101 samples, and you'll notice the distribution is a little bit all over the place there. It's a lot more spread out. Look at that, some up, some down, a lot in the middle. And I can just continue clicking Draw, and it's additive. So it takes the samples that I'm continuing to make, these new 100, and puts it in with everything else. Right now, I'm at 501. And of course, as you're doing this, students, as they work individually, should be able to see, hey, I'm starting to see a shape forming here, a fairly predictive shape, something that is very close to what I've seen before. Okay, so here we go. I'm at 1,501 for my piece. A couple nice pieces for you as a teacher. You'll notice down here on the bottom, the range of x values, it goes from 0 to 1, and these are my sample proportions. I could zoom in a little bit more, so maybe I want to go from, say, 0 to 20, and maybe that would be a little bit easier to look at. So you can select the range and go down to, say, 20 and to 0, and there's the data now from 0 to 20. If you wanted to see the normal approximation, you can, just to kind of see the overlay. All right. Now this gives us a chance to see kind of how likely it was to get the first sample. The first sample I had was 0.992. If you look, it's kind of right in the middle. So I'm like, yeah, that's actually pretty much expected. But it's a great chance for discussion in a classroom where students might have lower numbers than others, and some have higher numbers than others. And understanding, what is this really representing about our distribution? not a bad idea to also talk about what does each one of these, there are 1,501 simulations, what does each individual little data value represent in this graph? So linking back to the idea of sampling distributions. Okay. For those of you looking to do more, yes, you can download the graphs. You can also do a screenshot of this and upload to your LMS. And if you're interested, down in the bottom, you can actually find the probability for the sampling distribution by clicking and saying at or below what value. And so if you put in a particular value, for example, if I put in 0.08, 0.08 would be 8%. And so what I can see is when I look over here at a kind of a vertical bar representing 8%, I can see the proportion is about 17% of the time I should be getting less than or equal to that value. Hope you enjoyed this piece. We'll have a few questions for you about this. Off you go.